Okay, here we're given the equation of a curve, and we're asked for the coordinates of the point C. Oh no, the point where C crosses the y-axis. So they want this point, right? So what's special about this point? At this point, we know that x equals 0. So we just need to put 0 there and 0 for every x. So you're going to have y equals 2 times e to the 0, which is 2 times 1, which is 2. So the coordinates, that means x and y, is 0, 2. So that's 2. Okay, so that was straightforward. You just needed to substitute 0 in there. Now it says show that it crosses the x-axis at x equals 2. So that's probably that point. So they want to find the coordinates of this point, and I guess the other point. Find the other point. So they want to find the roots of the equation. So when is this equal to 0? So let's give that a try. So if we write the equation y equals 0, so we can say 2x squared minus 5x plus 2 times e to the minus x equals 0. Okay. Is it possible to factorize this? It would be really helpful if we could, and because they're telling us x equals 2, it's pretty clear that we can factorize it. So it's almost certainly going to be x minus 2 times 2x minus 1. You can check. So x times 2x is 2x squared. Minus 2 times 2x is minus 4x. Minus another x gives you minus 5x. And minus 2 times minus 1 is plus 2. So that's correctly factorized. Now when you have three things that are multiplied to give you 0, then you can be certain that one of them has to be 0. Either x minus 2 is 0, or 2x minus 1 is 0, or e to the minus x is 0. So we need to solve each of these to find the points where the curve touches the axis. So x equals 2 is the first one, so we answered that. X equals a half is the second one, so if that's 2, this is going to be half. And e to the minus x, I don't think that's ever equal to 0. There's no value for x that will make e to the minus x 0, so that doesn't have a solution. So here, no solution. So this here is probably asymptotic. It never touches the x-axis. There's only two solutions. Okay, so that's the answer for part B. Now for part C, find dy by dx. That's going to be interesting. So this is our expression for y. Let's rewrite that here. So y equals 2x squared minus 5x plus 2 times e to the minus x. How would we find dy by dx? You'd need the product rule. Now remember, the product rule looks like this. Why do we need the product rule? Because there is a product, and a product means two things multiplied together. So whenever you have a multiplication, you use the product rule. So if y equals something times something else, uv, then y dash is u v dash plus u dash v. So dy by dx will be u v dash, so it's this, times the derivative of that. So it's 2x squared minus 5x plus 2 times the derivative, which is just minus e to the minus x. Plus u dash v. So plus the derivative of this times that. So that's going to be 4x minus 5 times e to the minus x. And you can probably leave it at that. You could take e to the minus x common, but I don't think that's necessary. That's the answer to find dy by dx. They say find the coordinates of the turning points of C, and they use the word hence. That means using what you just found. Now remember, whenever you see the word turning point, that means that dy by dx has to be equal to 0. So that's dy by dx. You need to make that equal to 0. Only at the turning point. All right, so we're going to say that. Then we're going to say equals 0. Okay, so that's at the turning point. So now I think it's useful if we were to take e to the minus x common. It's a common factor. And say that's e to the minus x multiplied by let's insert the minus sign and get that out of the way. And then it'll be plus 4x minus 5. Okay, so if that's equal to 0, then it's either this equal to 0 or that equal to 0. Now this we said can't be equal to 0, so this has to be equal to 0. So the 5 and 4 add up to 9, so you can say minus 2x squared plus 9x minus 5, I think it's 7, minus 7 equals to 0. Nobody likes a negative sign, so you could multiply everything by minus 1. That has the effect of changing negative to positive, positive to negative, negative to positive, and the 0 is unchanged. Now we can try to factorize this because it's quadratic. Now 2x squared is 2x multiplied by x. Because we have a positive sign here, a negative sign here, it means that these two signs have to be the same and negative. I don't think it's really going to be possible to get two numbers to multiply together to get 7. Yeah, and even if we put a 7 here and a 1 here, no, that might work actually. So 7, 1. So let's check. Minus 7x minus 2x gives you minus 9x, so that works. Now you've got two factors. When multiplied, they give you 0. That means one of them has to be equal to 0. So you solve each of these, and you end up with two values for x. X equals 1 and x equals 7 over 2. What was the question asking for? It says find the exact coordinates of the turning point, and it says turning points, so there's more than one point. So we found the two x's, we still need to find the two y's. So we still need to find the two y's. How would we find y? Well, we have the equation for y. just need to put the numbers in. So all you'd need to do is put that there, and again there, and you would replace x with 7 over 2, and here you'd replace x with 1. So that's something for your calculator. Let me try that. That gives me 0.27, and the second one gives me minus 0.37. So the turning points would be 7 over 2, 0.27, and 1 minus 0.37. So we're taking the x values from here that we found, and then the y values from here. So that's your final answer for this question, finding the turning points. Hence, find the exact coordinates of the turning